Okay, so let's get started. Today is we are going to talk about very important concept, inheritance. Okay, let's see. Yeah, the question from Paul: Will the recordings be available on the same day on Tuesdays? Yeah, that's my plan. Yes. So I'll probably record a day before on maybe every Monday, and I'll post it on Monday night or Tuesday morning. Okay, so inheritance. We'll talk about what is and why inheritance, and basically its reusability. We are going to talk about a special class called the object class, and then we are going to learn how to create a subclass. Okay, so we use the term derive. We derive a child class or subclass, those are the same thing, from a parent class. We'll talk about how constructor calling chain works between parent and child class. We'll talk about the super method and super keyword. And we'll talk about the concept of overriding. This is very important concept. We will talk about the concept of typecasting. Again, this is very important concept. And then we'll talk about final class and final method. So in this presentation, I would say this overriding method and typecasting, these are two most important concepts. So what is inheritance? So inheritance is a concept of child class or subclass automatically inheriting the properties and methods defined in the parent class. Okay, so terminology that we are going to use in this presentation is that parent class is the same thing as a superclass, and child class is the same thing as subclass. So I might interchangeably use these terms. So inheritance is one of the three primary object-oriented programming models, along with encapsulation and polymorphism. So why you want to use inheritance? It is mainly for reusability, because once you define a parent class, the behavior, which is represented by a set of methods from a parent class, and also a set of properties from a parent class, could be inherited by a child or a subclass. Okay, so let me just repeat, because this is important concept. Once a behavior, meaning a method, is defined in a super class, the behavior is automatically inherited by all subclasses. So basically, you write a method in a parent class, and all child classes will be able to access that method in a parent class. Same thing for the properties or fields. So once a set of fields are defined in a parent class, then all child classes can have those properties automatically. Now, so a subclass, the only thing it needs to implement are differences from the parent class. We're talking about different set of methods and different set of properties. So those are extra methods and properties in the subclass. So subclass will be able to inherit all the properties and methods of a parent class, and then it will add its own methods and properties. Okay, so we'll see examples of this moving forward, so we'll have a better understanding. Now, there is a special class called object class. So object class is a mother of all classes. So in fact, in Java, all classes are created from the object superclass. This is the top level superclass. In fact, object class is the only one that does not have a parent class, because it's the root class. So any class that you create, or any class that you see in JDK, it is indirectly or directly a subclass of object class. Now, because object class has a set of methods, for example, getClass method. GetClass method will return class object. equals method is also one of the methods defined in object class. So equals is basically providing the semantical behavior, whether it is in fact equals or not. In fact, as a default, it is detecting whether a particular object instance is the same thing, same instance as the other object instance. ToString is creating string from object instance. So by being a subclass of object class, these methods you can use right away for any object instances, because the classes that you create your object instances from are subclass of object class. So this picture shows class hierarchy. On the top we have object class. Then you could create child class called A and child class D from object class. And then you could create child class B from child class A. So in this case, A is parent class and B is a child class. And also C is a child class of class A. Now all these guys are in fact subclasses of object class. Okay, so how do you create a subclass? Or how do you derive a subclass from a parent class? So there is a keyword called extends. This is the keyword that you want to use to create a subclass. So let's see an example. So let's say we have a parent class called person. So this person has a set of fields, name and address. And it also has a constructor method, and it has a set of its own methods as well. Now, if I want to create a subclass called a student, you are going to use extends keyword. So this is an example. So here we are trying to create student class, and we know student is also a person, so it makes sense to extend person class because we want to inherit all the characteristic of person class, meaning all the fields like a name and address and the set of methods from person class. So we are creating child class called student from person class by using extends keyword. Okay, so this extends is the word that you want to use to create child subclass. And child subclass can have its own constructor method and set of properties and set of methods. Okay, so what you can do in a subclass. So as we talked about, a subclass inherits all the public and protected members. By members, I'm talking about fields as well as methods of its parent, no matter what package its subclass is in. If the subclass is in the same package as its parent, then it also inherits package private members. These are we call default modifiers. So this is something that we covered in previous sessions. So for now, for you understand, the thing you want to understand is that subclass is basically inheriting fields and methods of a parent. Okay, so that is. So I think in previous slide we talked about the methods. Here, so field and methods. So this is a bit of repeat. Okay, so what you can do with inherited fields. Those inherited fields from a parent class can be used directly, just like any other fields. So in a child class, it's like it's having those fields itself. You can also declare new fields in a child class. And of course, those new fields are not in the parent class. And also, subclass does not inherit private members of the parent class. So private members are private to that particular class. So even though you are a child class, private members are not accessible in your child class. Okay, so what you can do in your child or subclass regarding methods. again, the inherited methods of your parent class can be used directly in your subclass. You can also add new instance methods in your subclass. Again, these are your new methods not present in the parent class. Okay, and we are going to talk about the concept of overriding. So you can add the new methods that are not present in the parent class, or you can actually add method that has the same signature. In that case, we are saying is overriding it. Okay. Yeah, so this is the overriding case, and this is the case that you are adding new methods. Okay, so we'll see examples of this. Okay, moving forward. Constructor calling chain. So we learned, whenever you create an object instance, a constructor method of that class will be invoked. So in the constructor method, typically you're going to perform some initialization. Okay. Now, when an object instance of subclass gets called, of course, subclass's constructor will be invoked, right? Now, before subclass's constructor method gets invoked, it will call the parent class's constructor. So in this example, let's say we have a student class, which is a subclass of person class. Okay? So when we create student object, the default constructor of its parent, in this case person class, will be invoked automatically before student object, in this case child class's constructor, gets invoked. So if you have, let's say, 3 levels of inheritance, for example, you have person on the top, then you have a student in the middle, meaning student is a child class of a person. Then if you create a child class of student, like international student class, and then when you create international student object, meaning instantiating international student class, what happens is that before international student constructor gets called, it will try to call parent, its own parent, in this case student class's constructor, and then before student class's constructor gets called, it will call its parent, in this case person. Okay, so person's constructor gets called, and then student constructor gets called, and then international student constructor gets called. Okay, so now subclass's constructor can invoke the constructor of super class explicitly by using super keyword. So if you're not using super keyword, meaning super method, then this behavior will be followed, meaning default constructor. By the way, default constructor is a constructor that does not have arguments. Okay, so constructors of parents will be called in chain. Now, if you are explicitly calling super method, meaning you are basically calling constructor method of your parent class by using super, that is the one that gets used rather than implicit or automatic invocation. Okay, so let me just repeat this one more time. A subclass constructor can invoke constructor of the superclass or parent class explicitly by using super method. In that case, the constructor of, so example wise here, so suppose we have student and person class. The constructor of student class can explicitly invoke constructor of a person class using super method. Okay, and this is typically used when you have to pass parameters to the constructor of a parent class. So let's see an example. So let's say we have a person class. This is the parent class, and it has default constructor person, and when this constructor is called, we are going to display person constructor is called. And then we have a student class which extends a person, so student class is a child class. So student has his own constructor, default constructor, and here when this default constructor is called, we are going to display student constructor is called. So in the main class, we are going to create student object, okay, by using new keyword. At this point, what happens is the constructor method of student will be first of all invoked. Now, before it gets called, it will see whether it is a parent or not. If it is a parent, the parent default construct gets called first. And if the parent, in this case a person, is also a child class of another parent class, that parent class will be called before. The parent constructor method will be called before person. So in this example, you will see person constructor is called first, and then student constructor called is next. Okay? Question from Roman. Can an abstract class have a constructor? Does it have to have a constructor? So we haven't learned the abstract class yet. We haven't learned interface for that matter yet. The answer is no. Okay? All right. So we'll move forward. We'll deal with that, the issue a bit more detail when we deal abstract class and interface. So this picture actually shows what happens. So here we have a person class which has default constructor called the person method, and then student class which has a student default constructor. So when we create a student object here using new student, and what happens is it's going to call student constructor. Now before student constructor gets called, it will check whether it has a parent class or not. So it will see whether it has a parent. So it has a parent class called the person. So parent class's constructor gets called, and then it will return to the control to this student constructor, and whatever student constructor things will be performed, and so that's what happens. Okay. The question from Roman is the default constructor is always public. Not always. In general, that's the case, but you can have your default constructor as a private, and there are some cases you want to do that. Moving forward, slide number 19, super method and super dot property name. Okay, so as I said before, you can call super method to invoke the constructor of your parent class. So a subclass can also explicitly call a constructor of its immediate superclass, meaning its parent class. This is in replacement of the default behavior of constructor call chaining, where default constructors are called. So if you're not explicitly calling, then default constructor chain will be invoked. However, if you're using super, and that's what gets called. Okay, so you can use a super constructor method like this. So a super constructor call in a constructor of a subclass will result in the execution of relevant constructor from a superclass based on arguments passed. So you can pass arguments as well when you call super method. So let's see an example. So here in slide number 21, we have person superclass. This is a parent class. This is a default constructor. And then we have another constructor that takes name argument. Okay. And then we have student child class, which extends person parent class. And here it has a default constructor. And then it also has another constructor that takes, in this case, 3 arguments. So here, when this student constructor with 3 arguments are passed, when this is invoked, you can call super and you can pass anything you want. So here we are passing a name, and of course, when you are calling super name, there has to be a constructor method in the parent that takes this particular type of argument. If person class does not have this one, and when you try to call this one, that's a compile error. Okay. All right. So here, this is an example where you can explicitly, or you want to explicitly call your parent class's constructor. Okay. All right. Another question from, it's not from Roman. Question from Mahesh. What happens in the absence of default constructor? Okay. Oops. All right. Can people hear me okay? Yes, somehow I'm listening some static noise. Can you hear me? Okay, so it's better. Can people hear me okay? I don't know why I'm actually listening static noise. Okay, so I hope people can listen to me okay? Yeah, if you do, can you actually send back the response? Can people hear me okay? Yeah, so if the network connection is still there. Okay, good. Yeah, all right. Yeah, okay, good. Yeah, you can hear me. Excellent. Okay, so the question from, let's see, the question from the Mahesh. What happens in the absence of default constructor? In fact, this is actually an important question. Yeah, sorry, if you hear noise here, I'm actually staying in the lobby of the hotel. Actually, not lobby, but the conference room in the hotel, and the people actually playing some game outside. So, my apology. So, let me repeat the question again. So, what happens in the absence of default constructor? If you do not have any constructor in your class, then default constructor will be automatically added. Okay? That's important. If you have any constructor in your class, then default constructor is not going to be added. So that's the behavior. Okay, moving forward. So the super method, a couple of things to remember when you're using super method. So this super method must occur as a first statement in a constructor. You cannot use it as a second statement, for example, after another statement, except the comment, of course. Okay, so if you try to use the super method right after another statement, then that's a compile error. And you can use this super method only in a constructor. If you try to use this super in any other place, then again, that's a compile error. Okay, so let me see whether I can see all the questions. Okay. All right, good. Yeah, so I'm still hearing some static noise in myself, so it might not be the best condition, but let's actually move ahead. Okay, so that's a super method. Now you can also use a super to access a property of a parent class. Okay, so here, suppose I have a student class, this is a child class, and then I can set the name field of a parent class with some value. Same thing with the address. So, parent class has a name and address fields, right? And I can access those parent classes fields by using super, the keyword. Okay? All right. Now, moving forward, overriding methods. So this is important concept. So what do I mean by overriding method or method overriding? So those are the two same things. Those are the same things. When a child class needs to have a different implementation of certain instance method from the parent class, you can override that method by redefining the method. That is called the overriding. Okay. Now, the overriding happens only for instance method. Okay, you cannot override static method. In fact, it's called the hiding method, and this is not that much important. So, we are not going to actually cover these hiding method things. What's important is instance method. Okay, so the overriding method, however, has to have a same name and same number of and same type of arguments. Okay, and the same return type. Okay. As far as return type is concerned, the overriding method can return subtype of the type returned by the overriding method. But in terms of the name and in terms of the number of arguments and their types, they have to be exactly the same. That's overriding. If they are different, they are considered as a different method, meaning new method. Okay? So let's see an example. Suppose I have a parent class called person. Yeah, same parent class. Now suppose we have a method called the getName. Okay, so this is the name. This is the a method defined in a parent class. And in this case, the behavior that is defined by the parent class is displaying parent and getName and then returning name. Now, I don't want this behavior as the behavior of this method in my child class. In that case, I can override it, meaning I can redefine this method. Okay, and it has to be exactly the same name. And then in this case, we don't have any set of parameters, but those set of parameters has to be exactly the same type. And of course, it has to be the same number of the arguments. And the type, return type, has to be compatible. So this is an example of overriding parent method. So this is the student child class. It extends parent person class. And now I want a different behavior as far as the get name method is concerned. So I am actually providing exactly same name method. And here, because I don't have any arguments to, pass, this is nothing. And then here, I'm displaying student get name instead of the person get name. So when student object gets called, and then get name method of the student object gets called, it is this method, student method, that gets executed rather than parent version of it. Okay, so now when we are invoking get name method of the student, this is what I just talked about. When get name method of student object is invoked, it is the get name method of the student that gets executed, not the parent version. So you will actually see student get name displayed. Okay, so this is example of child class is overriding parent method to have a different behavior. Now, if you have get name 1, that is a different method. Okay, so that is considered as a different method. So name has to be the same, and also set of number of arguments and the types of those arguments should be the same. Okay. Okay, so in terms of return type, the return type could be subtype of the parent method. Okay, so in this case, we are using string. In this case, we are using the same type. Okay, but suppose a parent is returning, let's say get name is returning, let's say number type. Okay, then you can define in the child like a float. Float is a subtype of number, so that is considered as overriding. Okay, so that is in response to Mahesh's question. Please elaborate subtype return on override method. Okay, so this return type, in this case we are using same type string, but return type could be the subtype of parent method type, this guy. Okay, all right, so moving forward. Modifiers in overriding methods. So access modifier, access specifier for an overriding method in a child class can allow more but not less access than the overwritten method in the parent class. For example, protected instance method of the super class can be made public but not private and in the subclass. So subclass can be a bit bigger scope in a sense. Okay, but in general, you want to actually use the same the modifier type, okay, and same return type. That's in fact the better practice. But syntax-wise, this is allowed. So you will get a compiler if you attempt to change the instance method in the superclass to a class method in a subclass and vice versa. Oh, okay. So you cannot, you cannot overwrite, let's say, instance method with the static method or vice versa. That's a compiler. Okay, moving forward. Another important concept is typecasting. So typecasting is, so let's talk about the concept of type first. When an object instance is created from a class, we say that object instance is the type of that class and is superclass. So let's see an example of this. We create student object. Okay, and the student is also a child class of a person, and person class is a child class of, actually not directly childly a class of object. Okay, or it could be it's also a child